In this episode I'm going to talk about Panda3D's scene graph. So what is the scene graph? Scene graph is a tree-like structure. So every tree-like structure has a root node, and in Panda's case this root node is the render, so which is the top of this scene graph or of this tree. So everything what you want to make visible, you have to reparent it to the render. So these are the childs of the render node. In this tree structure, everything is a node. So the renderer is a node, a cube is a node, which is the child of the renderer. This sphere 2 is also a node, and this sphere 2 is a child of the cube, which is a child of the renderer. So, or the cube is the parent of the sphere 2. This sphere is also a node, which is a child of the renderer. And this empty notepad is the child of the renderer, and this empty notepad has a child, which is the panda. So we can create all sorts of graphs or tree-like structures using this method. So everything, as I said, which is parented to the renderer, or it is a child of a node which is parented to the renderer, like in this case or in this case. So the sphere is not directly a child of the renderer, but it is a grandchild. So its parent is the cube, which is the child of the renderer. So this is some kind of this scene graph is a concept which are used in many graphical engines and game engines for actually rendering. And I'm going back a little bit to PyCharm. I'm just created here a cube, loaded here a cube model, and I reparented this to the self.renderer. So we have a cube which is parented to the renderer, which is the root. And I'm also created here a monkey. Loaded here the monkey model and reparented this to the renderer. So now if I run it, of course they are both visible, and they are both in the same place, so in the 0, 0 coordinate. So I can make like something like this, where I'm going to parent the monkey to the cube. So instead of parenting the monkey to the self.renderer, I'm going to parent it to the self.cube, although it is not self but just cube. And although I didn't parented the monkey to the renderer, but it is still visible because I'm parented this to the cube, which is parented to the renderer. And now if I parent the monkey to the cube as its child, it also inherits its parent's transformations, so its position, its location, its scale, its rotations. So I'm going to talk about a little bit about this concept of parenting. So I'm going to open up Blender, and let's say I have this cube, and also going to parent this cube to this camera. So Ctrl P and keep transform. So I can move the cube without moving the camera. So the cube in this case is the child, but if I move the camera, its child moves with it. So it moves relative to its parent. So let me create another, let's say, icosphere. I'm going to move this icosphere on the x-axis, and I'm going to make the icosphere a child of the cube. So I'm select the icosphere, select the cube, Ctrl P, and object keep transform. So now I can move the icosphere wherever I want. It moves by itself, but when I move its parent, which is the cube, it also moves its child, which is the icosphere. And if I rotate it, it rotates also the child relative to its parent. You can also create empty notepads in Panda, similar like in Blender. So if I create here an empty arrows, and I'm going to make this cube a child of this empty, so Ctrl P and parent it. So you can also do this in Panda. Just create an empty notepad and add child to it. In this case, this is the cube, which is the child of this empty. And I'm going back to Inkscape, which is this right notepad. We have an empty notepad and its child. In this case, this is a pentagon. And if you, as in Blender, it's the same in Panda. If you move now this empty, it moves all the childs and all the grandchilds. But if you want to move only the child, you can do that and move only the child, and the empty is unaffected. And you can also move the grandchild separately from its parent or its grandparent. So the same concept works also in Panda. You can create empties, but you don't have to, of course. But you can create empties. These empties can hold another nodes, or you can directly just parent your geometry nodes or notepads to your renderer. In this case, in Blender's case, this is the camera. So if you wanna know more about the scene graph in Panda3D, just search for it, Panda3D scene graph, and open up the documentation, and you will find some nice explanations. And one thing I wanted to show you at the end of this video is, if I run this program, you can see I have this scene graph analyzer matter here in the upper left corner, which shows how many node instances we have. So number of nodes 9, instances 0, transforms 1, nodes with attributes, geometry nodes, geometries. So if you want to make this visible, you can set it in your config variables, show scene graph analyzer matter, set it to 1, or alternatively you can set it to true. And I'm going to set back to 1. And another way to actually show this scene graph analyzer, I'm just going to comment this out, so you can use just a regular Python comment. So now if I run, and the scene graph analyzer is not visible. Another way to actually show the scene graph analyzer is just by calling this method. So self.set scene graph analyzer matter to true. And we have the same result. So in the next video I'm just going to talk about the Panda nodes and also the notepads a little bit.